Hello, and welcome to TSQL for Beginners. I am Kendra Little from Redgate, and today we are going to talk about some fun topics. We're going to go over the solutions for the window function homework, and then we are also going to look at windowing functions, which is some of my favorite functionality. So here is the GitHub repo where I keep all the course info. Here's all the files, and here's the syllabus, which I have updated. So this week we are doing this module right here. So if we jump on down, the files that we will be covering is file number 18, TVFs solutions, and then we'll be doing windowing function demos. And oh, this should say 20. How did I get that wrong? But the link still works. It's just it still links to the wrong file. So we will go ahead and fix that on the fly. So this is all in readme.md. And I can use this little link and jump down here. And in Azure Data Studio, where I actually edit this code and connect to GitHub, I'm just going to copy the relative path here. We will paste in the relative path there into our little markdown file, paste it there. We will save, and we will now commit this change. So updated wrong link for homework. Save that. Stage the change and go ahead and push it up there. So that should be fixed right now. So with that, let's go ahead and get started. We're going to open up the solutions for the table valued function homework. That's file number 18. And let's get going. So up at the top of the file, we're doing a little bit of cross apply. So we are once again using the Wide World Importers database. And question number 1, this is a multiple part question where we're going to first write a table valued function. Then we are going to write 2 queries that use the table valued function. The first one will use it in a subquery. The second one will use a cross apply, a join like thing. That's how I like to describe cross apply. It's a join like thing to use the table valued function. So this is the way that the function is going to be defined. I do apologize for using this name. So I have named this DBO invoice count TVF. Please don't take it from me that this pattern is any good. So that you will come across some code where like the name of the object has something in it to indicate what type of object it is. That is often kind of frowned upon. So historically, some people have done it. Just it's usually for a new code base, not good to put in there. Just name it invoice count. People will figure out it's a table valued function. That is the modern way to do this. However, the only reason I did this is we already created an invoice count for Scalar UDF, and maybe you want to compare them. Maybe you want to have both at the same time. I didn't want to just replace it because I wanted you to be able to compare them if you want. So that's why I'm using that naming convention. It is generally not a good thing to put the type of table into the object name itself. Yes, I have been guilty of this many times in my life, so I'm not going to throw any stones here. So you can read the instructions yourself. We're going to just talk about the solution. So here is the solution for the function. We want it to take an integer parameter, return a 1-column table, and it's going to count the number of invoices in the sales.invoices table for that customer ID and just return the count. So if we are returning only 1 column and we're just returning the count, that's only going to be in 1 row. So this is going to return 1 column and 1 row. So this is written as a table valued function. And I can do, as of SQL Server 2016 Service Pack 2, I can use create or alter, which is really, really useful. I love that they finally gave us create or alter. Very nice instead of having to do all of these checks if something exists. I'm taking in a customer ID, which is an integer. I am returning a table. That's, if it was scalar, I would be returning a data, one thing that's a data type, right? So this could be many columns. So I'm saying return a table. And then I wrote this as a single statement table valued function where I just said return whatever this query returns. Now, it does do some enforcement on you, I think. What if I didn't tell it what the name of this table was, and I tried to create the function? It does require me to do certain things in the query, right? I have to give it a column name, but it can be pretty flexible. So this is always going to return, because of just the nature of the query, I know that this is always going to return one row and one column from this table. So let's make sure I actually got that created. Now, we're going to use this in the first one in part two. In part two, the first way we're using this, we're writing this with a subquery in the select. And then we're going to try to return the same data using a cross apply. So these next two things are just two ways to write the same query. And what we want to do is use the function along with the sales.customer table to return the top 10 rows, or the top 10 customers who have like the highest invoice count. So this first one, using it as a subquery in the select list, looks like this. So I could actually run, right? This is the type of subquery where there's no correlation or anything in here. I could actually just highlight, I could actually just highlight this if I highlight the whole thing, right? I hadn't highlighted the alias as F, and it selects F.invoice count. Oh, wait. No, I am correlating. I'm blind. I am selecting inside here. Is this called correlating? I don't know if this is called correlating, but I can't run it by itself, right? Because I'm taking from the sales.customers table, I'm passing in the customer ID into there. I do have to pass in a customer ID. Yeah, I just had a moment in outer space where I thought I could run that query by itself. No. With the table valued function in here, I have to pass something into the table valued function to get meaningful results. What if I ran this and passed nothing in, right? What if I just passed in no customer ID? Well, the query inside, come on, run. And I, again, need to have proper syntax. It says it's going to be getting a customer ID, right? So if I run this and I'm not passing anything in, I quite rightly get a message that I have not supplied something that it has to have. This message, the multi-part I still have a syntax error. Working through syntax errors. So I actually had two errors in there, right? I had a syntax error, and then also I was passing in an insufficient number of arguments. So now I've narrowed it down and I just have the one error. But yeah, this does require that I put something in there. Now, of course, I could put in a literal value. I could just say customer ID 15, right? I don't have to pull that from a table, but I can pull that from a table. In this case, if I just say, customer ID 15, it has 100, or they have 114 invoices, right? So instead of passing in a number, I'm going to take the number in sales.customers, the customer ID column, and pass it in for every row in the table. And then I'm going to reference that as invoice count. So if we run this and return it, we get 10 rows back. And the highest amount is 144. The lowest amount is 135. We could also write this with a cross apply this way. So if we didn't want to put a subquery up here, we could say instead, with a table valued function, a way that we can kind of join to it is we can say cross apply, and then in parentheses, put the query in there. And again, I'm passing in c.customer ID, which is from the customers table above. So I can pass in inside these parentheses, I can reference columns and tables outside of the parentheses in the query too. And now I'm treating the results of this as a table. So I'm cross-applying this as I see. Now this is different from a join, because with a join, you would say with join syntax, like here, right? When we write a join, we're saying, I want to join this on the, c.column name equals i.column name. In a cross apply, it's just a little different, because in a cross apply, The join is in this case, right, it's inside the function itself. I'm not doing like join on, but inside the definition of this itself, I said I want to, for every c.customer ID, for every customer ID in the table, I want to run this function, and the output of that's going to be a table. So it's weird. I think it can be very confusing, flipping back and forth between, you're like, oh, I need to write a join. How does that work? Oh, I need to write a cross supply. How does that work? If you practice writing them, it becomes a little more natural and it stops seeming as weird. But I think in my experience, it was quite weird at first to be like, oh, with join, you put these join criteria after, but in cross supply, the thing that you're actually connecting from this table into the other one is actually specified in the middle, not afterward. But our results are the same if we take a look at this. So let's run them both at once, just for funsies. And in this case, there actually is a little detail that we could get different results from these. We'll talk about this in a sec. So in this case, our first two and our last two rows are exactly the same here, right? Now, the syntax is equivalent, but you could get different results is what I'm saying. So why could we get different results if they are logically equivalent? Right? That seems weird. If they are logically equivalent, why could I get different results? So there's something to think about here, and that is that I'm using top and an order by on a column where I haven't. Let's run this with something different on our top. So the top operator has an option where you can say with ties. This is the same. We could actually, let's just copy with ties for fun, and we'll add it to example B, right? You can use with ties on any of these syntaxes, whether you're using a table valued function or not. So I'll just add with ties here. If I add with ties, I get back 13 rows. Not 10 rows. I did a top 10 with ties. And the reason I get back 13 rows is that there are multiple customers who have 135 orders. So if I say top with ties, it's like, okay, I want the top 10, but if they tie, go ahead and include them, because I have only ordered by invoice count. And if I'm ordering by this column and only by that column, and I want 10, then which of these 5 should I get in the top 10, right? Like, I haven't said, I've only said order by the invoice count. I haven't said, do I want them alphabetical? And they aren't alphabetical, right? Like B, I, O, right? Like they're in whatever order happened to come up. So I could get them, I could run this query right now, and then I could run this query tomorrow, and it could decide to order them in a slightly different way if behind the scenes if I was just using top 10, like with top 10 with ties, I'm going to get the same rows, but I've only specified ordering requirements on one column. So this is just something to know about top is SQL Server, if you're using different syntax, and it's fine to use different syntax, right? Between these two queries, they are functionally equivalent, but they just have different syntaxes. So when I compile an execution plan, let's compare let's auto scroll too fast. When I compare their execution plans with a more moderate slow scroll, in this case, they are the same, but they aren't guaranteed to be the same. And they could, depending on, and certain things, there's complexities that, especially if you're using parameters or things like that, things might get different plans at times. But right, they're not guaranteed to get the same plan. So they could happen to get a different plan, and they might decide, depending on whether there happens to be at any given time where it chooses to put the sort operator and what it's sorting on, different things can happen. So in other words, if we want to make sure that we're always, like if we might have ties in a situation, we should probably either decide if we want the ties, right? If we're okay with having more than 10 rows, then we should say put in with ties. If we only want 10 rows, then we want to do something like specify, okay, what is the tiebreaker column, right? So I could say I want customer name as my tiebreaker column, and then I will have a guaranteed sort order, And I will always get, consistent results no matter where sort operators or whatever ends up in the execution plan. Oh, and in this one, I made an error here. I was like, this isn't right at all. 4 shouldn't be at the top. So I added in my new column name right here, and I let the descending go after it. The default ordering is ascending. So what I have actually just told it is order first by invoice count ascending, then order by customer name descending. So what I actually meant to do was the following. I meant to add, I should have added the column at the very end, and then it is nice, I think, to specify the ordering. So this is it. So it's going to order first by the invoice count, and then if there is a tie, it's going to use the customer name as the tiebreaker. So that's just one of those things to know about with top. It is not specific to the window, or it's not specific to the table valued function. But it's one of those things with top that's worth knowing. So, and with ties is very, very handy. All right, question number 2. So this is a multiple parter, exact same thing where we're writing a function and then using it in 2 queries. So this one is initials TVFs. So again, this is really similar to what we did we did a scalar function for this, and this one doesn't do data access. So we're creating it again with schema binding. When we did the scalar function, we created it with schema binding. I actually can't remember. I know that performance improvement, like it's a best practice to create, if functions don't read data from a table, it's a best practice to create them with schema binding for scalar functions. There's no downside to doing it for table valued functions. I just don't know if there's actually a performance benefit. But like when we say with schema binding, we are not binding the schema of anything in here because we aren't referencing a table. So there isn't really a downside that I know of. So here's what the function for initials TVF looks like. It's the exact same rules as when we did this for the scalar functions. Like we can just assume that everyone, that the full name column is all formatted in the same way and we don't have any data issues. So in this case, I am, again, creating the function taking in full name, which is Unicode variable 100. You always want to make sure that this matches. So you want to check the table. In this case, I gave the parameter here, but if we know we're going to put in a certain size, we should always give that size. Now, we always want to make sure it's the right size, because what if I said it's going to only allow space for 4 and I needed to pass in space for full names that were 256 characters? Do be careful, though. Don't fall into this trap. So you might be like, well, I don't know exactly how big it's going to be. And this is a reasonable thought process. I've had this myself. It might be really big. So I am going to look for the biggest possible thing that might ever be put in and try putting that in, right? If I try to create it this way, it will do this. This is just in general a pattern. You don't want to just use super large data types to be safe. It will create problems in different weird areas. Like if you do this with columns in a table, there are certain kinds of indexes you can't create on columns that are this max size that allow massive things in them. They get stored in a different way off page. So it is worth taking the time to try to figure out, okay, what is the right size to create this and the right size that it'll be used for, and don't just default to very large numbers in any kind of object you create. And you also want to make sure that Unicode matches with non-Unicode. So, okay, will we be using this with varchar or in varchar? There is a separate battle about whether it's varchar or varchar, and I just alternately use different pronunciations myself. So I try not to pick a side. So in this case, I am just saying return, select this. I don't have to even have a from in there, right? I can write a select statement without a from. I can just say select foo, right? And select foo. Or I can say select left foo 1, and that should give me an F, right? So I can return Like this returned a 1-row, 1-column table with that syntax. I can just say I want to return the left of full name, which we've passed in, the left 1 character plus a period, plus, and then I'm using substring to find where is the first occurrence of a space in there, and I want to go 1 to the right, because I'm assuming everything is formatted with first name space last name, and then I want to get just 1 character out of it using the substring function as the initials. So similarly to the last one, we are saying I'm getting this from application.people and I'm passing in the full name column. Now, I should have probably qualified this. I think it's clear if I give this an alias and then I specify the alias here. I think that's actually a little clearer and it would be better written that way. But I can run it there, and that way I can at least kind of match up something from there to there. I don't have to put an alias there. I don't have to specify the table name there. There's only 1 table name to choose from, so we probably could figure it out. But I kind of think that's clear. Now, there are some cases where not everyone, this doesn't always work, right? In this example, in this row, there's actually 2 spaces between there, so it actually picked up an empty space. You don't have to write the function to, you could get real complicated and you can make it handle that situation if you want, but you didn't have to for this challenge. Now, this is what it looks like in the cross apply. We are passing in the full name there into the middle of the cross apply, and similarly, it brings back the same results with the same problems for Alexandra. Of course, we could just put this in the query itself. In this case, if I compare, let's look at the estimated plans for all 3 of these. Whether I am putting the substring in, or putting the table valued function in the select, or whether I am putting it in a cross apply, or whether I am not using a function at all, in this case, SQL Server actually simplifies them all to the exact same thing, right? There is no function call in this query. It has simply looked at what the table valued function is doing. And because the table valued function was written as a single statement, because there's no begin or end, because there's no declaration of a table variable, it simply returned this. It was able to suck the logic from inside the function and just rewrite the query with it. So whenever we write a table valued function, if we can possibly just return a select query, that is generally going to be the best pattern to use for that. This time, we want to use a built-in dynamic management view in SQL Server. So if you have DBA style leanings or ever do DBA style work, if you're a database administrator, often database administrators query built-in objects in SQL Server that provide lots of information about the database because they just need to figure out just a variety of things as part of their work. This one is a very frequently used one that, let's say I'm curious how much fragmentation is in my table. Tables can get fragmented in SQL Server, and there's a lot of geeky internals on this, but essentially the biggest deal with fragmentation these days is that if you have a lot of fragmentation, you could actually be wasting a lot of space in your database. Yeah, there's other kinds of fragmentation too, but often these days this is the biggest deal. So I might have an index or a table with an index often that takes up, if I have a fragmented index, that it might take up 5 gigs, and maybe like a gig of that is empty, right? So we could inspect this using this built-in dynamic management view named sys.dmdb index physical stats. And it is a table valued function that is in every SQL Server database since SQL Server 2005. And we want to return all the rows for the current database, for all tables, for all partitions, and in this case, just use null for all. I just gave that one away. You didn't have to read all the documentation. And we want to run in detailed mode. We're going to look only at index ID equals 1. If a table in SQL Server has an index with this ID, like index ID equals 1, it always means that the table itself is ordered by 1 or more columns in the table. So in other words, I might have a table where everyone had a person ID. If I created a clustered index on person ID, I would have the physical ordering of the table just ordered where person ID 1 is before person ID 2 is before person ID 3, and so on, right? So a clustered index orders the base way in which all the data in the table is stored itself, and it will always have index ID 1. If a table doesn't have a clustered index, it will have an index ID of 0, by the way. Like, you only can ever have a 0 or a 1 there. And then there's something called level 0. If it is an index, if it had an index of some type, it'll have tiering. You don't have to really worry about it. It's just an example. Like, so the challenge was really meant to be figuring out what things do I pass into the function and then what things do I need to put into the where clause, because we can actually do both, right? So I am reading from sys.dmdb index physical stats. And this takes it takes 5 different parameters in it. Now you can look them up in the documentation, but what the 5 parameters are is first, database ID. Now we do want this from a specific database. So you could look up what is the current database ID. You could say, what is DB underscore ID, right? My current database ID is 10, right? So if you wanted to, you could hard code that in there. That is also correct, right? You could just hard code that in there. That's not incorrect, but if you want to, you could just put, let's just undo that. If you want to, you can just put another function into your function call, right? So I can put dbid, the function call, what is my current database, right into that itself if I want to, right? So you can put a static in there or not. So that's database ID. The next one it takes is object ID. And the reason I know this right off the top of my head is that I've used this function more times in my life than should be true. We want all, what if we just made this empty, right? If I just skipped this and I tried to run the query, I have incorrect syntax. What if I put an empty string, right? That's saying I want objects with an ID of blank. Surprised I do get something back there. I got 65. That's interesting. Wow, I didn't know that worked. I would still say that's not something I would rely on because that's not the same as null. How many objects do I get back if I say null? I get 65. Wow, I didn't know empty string did that in this. I learned something by experimenting. I would encourage you to use null on this one because I think that's what the documentation says to do. So that's object ID. If I specified an object, I would just get the fragmentation for whatever that object ID was. So if I said 19, I have no idea what object ID 19 is. We don't get anything back because it's probably like a system object, right? So if I put something that doesn't exist in there, do we have 110? Yeah, actually, that's interesting. So now I got an error that I couldn't find it. But before, I suspect what's happening with these super low object IDs is that they're protected operating system objects. Oh, or I do still have, maybe they just don't have an index ID equals 1. Let's run it without, no, not getting anything in there either. Right, so generally you want to make sure you're running it for an object ID that exists. So now I've said I want this database. This is for object ID, right? And I do have a tooltip here. I have an extension helping me know what that column is. And I think it may have even come from down there, right? Yeah, my tooltip isn't even helping me on this one. You do have to look it up in the docs. This next one is index ID, right? So I could put a 1 in here, right? See how I have index ID equals 1 down here? Let's make sure that I'm going to add something extra to my query, just index ID here, right? And I need to add a comma, right? So now I've got index ID there. We should only see index ID 1s if this works, correct? Parameter 3 is incorrect for this statement. All right, sys.dmd, let's look at the docs. I will be actually overjoyed if I remembered these column names wrong. Okay, database ID, object ID, index ID. Database ID, object ID, index ID. Oh, well, there is one syntax problem here. I commented out the where, and I just left an and there. So let's fix that. That was a very specific error. Parameter 3, yeah, parameter 3 is incorrect. Oh, let's look at the data type we need to pass in. So much fun. Index ID is the ID of the index. Index ID is int. All right, I always like to go look at the examples, right? So here, this one's a null. Like this one is a string here. I mean, passing a parameter, 0. 0 is a number, right? Just passing in an integer. DBID null. What have I done? What if this should not work. Yeah, like that's not right. All right, we're going to switch it back to null and just make sure it works with it as null. Okay? Yeah. Okay, so with that as null, that works. Let's show the whole query. I took out the where, so I am getting index IDs of different values back, right? That is expected because I'm saying all object IDs. Oh, I remember what the limitation is. You can only specify, although I think I remember what this is. Let's test it. Oh yeah, so notice that it specified the object ID before the index ID. I believe that to get only specific index IDs out of there, just because of the way they implemented the function on the inside, which we can't see. I cannot just leave this one null and specify this one. It probably says that up here, and I was just too impatient to read it. If you specify null for index ID, no, well I bet it's above this. Ha ha ha. If you specify null for object ID, you must also specify null for index ID and partition number. So it was actually above where I went to in the documentation. So that's why that doesn't work. And that's why we must put this down here. So in other words, I could specify, let's figure out an object ID. We'll use the built-in object ID function and we'll do from application.people. And then we'll do, we want select object name of, and then you pass in an object name itself. I think for this, I do have to pass it in as a string. So I'll put it in single quotes. Okay, this is an example of an object ID in this database. It's not really a small number, right? So if I put an object ID there, I can put index ID 1 there. That's what it is. So that will work. But if I want to put null here, I cannot do that. Now I get a syntax error. However, I can specify this in my where clause. So if I want, I did an accidental paste there, I think. If I want to get only index ID 1 back, I do have to return all of them from the function, but then I can add a predicate here saying index ID 1. This is partition ID in case the table is partitioned. And then this is the mode this is run in. There's a couple different modes in the documentation. It actually covers it of just the level, the way it scans, and the different values you can use for this. And there is some, if you want to learn about all of these, I think it may be under scanning modes. Yeah, this tells you what all of the different ones do. So if you have very large tables, they'll take different amounts of time. All right, that mystery solved. A mystery I set in place for myself, by the way. Two-parter, write a table valued function and then use it in a query. So we're going to create a single statement TVF. I did challenge you to look up the data types in this one, figure out the join columns also, and then use it in a query. So in this case, we're doing customers by state and country. And customers by state and country, this is an example where we put quite a lot of logic into the function itself, right? So the function itself has 3 joins in it. And for a table valued function, this is still one statement, but right, I'm putting all of the joins in there. So if I wanted to kind of predefine a query that people could use, I don't have to put this in a subquery or in an apply. I can just select from the table valued function and say, I want to know all of the customers who are in Washington for their state and United States for their country. And I could, of course, switch this to be like, I want all of the customers in Utah. I did not mean to push that button, so we'll just cancel. But what if I put in a state that didn't exist? Just T. In that case, I will get back no rows. Right. There we go, back to Washington. The next one is a 3-parter. And the next one is customers by state or country, not and country, but or country. So if you got the previous one, essentially what you can do is you can just change the syntax a little bit, because this one had an and here. We want their state province code to match this and their country name to match that. And of course, we could have taken in country code if we wanted to do it differently. We would just have to be able to specify it. In this one, we are just changing this for there's an or there. So in this one, what happens if I do put null in Washington? I get all of the people who are in Washington, regardless of what their country ID is, right? So this one is actually an interesting one. Or what if, like, our comparison here is actually or ct.country name equals null. And we did still get all the Washington ones back, right? So that's an interesting thing to know, because it's an or. It's not an and, right? So we met this side of it, but we didn't meet this side of it, and that's okay because of the or. Like if we did that with the and, let's just make this null. Right, we wouldn't get any rows back because nobody who's Washington has their country name also set to null in this data set. They could, right, in a data set. And then similarly, we could use that with the or, we could do it anyone who's in the United States with any country name. So in this one, if I did have something invalid in here, if the state was named T or the country was, United States, I would still get, something back because of the way the or works. All right, so that is the homework for a table valued functions. And next up, we are doing a little demo on window functions. These are another kind of built-in functions, and I think they're really fun. I hope you like them too. So we are now going to file number 19, window functions _ demo. And if I get my editor to go away, there we go. We are on this one using the TSQL school database again, and we are just going to drop and recreate the database. And this time we are putting in it just one table named doggos. It has a little bit of very simple information. Each dog has a, an integer that's just a number generated in the table. They have a name. They have an age. We know if it's a boy or a girl dog. And then this is just defining that the table has that. It has a clustered index on it. A clustered primary key is it's clustered there. That creates an index that orders the table. You don't really need one for this example, but it's often a best practice to generally create your tables with a clustered primary key in SQL Server. So I think I added the rows to it. Let's just rerun this. There we go. Did that work? Yes, that worked. All right, let's run some queries. So row number is a windowing function. And what is a window? Well, you will see what a window is. Notice that with row number, I'm saying I want to, row number is a function. It's going to be generating a row number for that row. So I do have an integer column in the table that is an identifier. This is not reading from dog ID though. This is generating a row number based on the dog's age. So I'm saying I want to generate a row number over this thing. over this window, I want to order by the age column descending. And I'm going to name this column row number. So if I look at this now, I can see that in my table, I've got one row for Mr. Mr. is aged 10. He is row number 1. Coda is also age named 10. Coda is row number 2. Why is Coda 2 and Mr. is 1? No reason. It just had to do that. It had to put them in some order. The only order I specified was age. I could say order by age and then doggo, order by their name. I would need to, as we discussed, I would need to actually specify the appropriate, and let's do dog name ascending, right? So we'll order by name alphabetically, by age descending, by name alphabetically. And now Coda is row number 1 because I specified I can get what I want if I specify. If I don't specify, I'm just going to get something. So I can now, right now these rows, I have these rows ordered with a row number. If I can look at what that dog ID is, that just happens to be the dog ID column. I think maybe it's doggo ID. Maybe it is dog ID. That just happens to be, that's part of the table, right? That was just generated when I inserted the rows because I have an identity column that says, an identity on this column means whenever you insert a row, I'll just give it an incremented higher number, in this case an integer, right? So this can be kind of useful, this row number thing, depending on how you want to order things and if you want to use that number later. So this is our first view of the window. We can actually use this, and it has even more cool stuff in lots of other ways. Now, sometimes you actually don't care about what the rows are ordered by, right? As we've shown before, select 1 over 0 is a divide by execution error, or a divide by 0 error. If I just want a row number and I don't care about the ordering, I do have to put something in here. Like I have to put some syntax in there. But if I just want arbitrary number, like this will actually work. Right? I actually don't care what it's ordering by. So as long as I don't put a column in there, right? I could also put select 1 in there and it would do the exact same thing. If I put a column name or 2 in there, as we did in the first one, right? We ordered by 2 column names. In that case, it actually had something meaningful to order by. In this case, all it's doing is it's checking, is there a column name in there? Oh, no, there's no column name in there. So I won't even look at it. But syntactically, like if I just say, order by nothing, this isn't going to work because it's like you have to have something in there, right? If I just don't put order by in there, similarly, it gets mad. I have to have something in there. But if I don't put a column name in there, you can put whatever you want and it will still work and just generate a row number for that column. And this can actually, in some query instances where you're like, oh crap, I don't have any unique number on my rows because the table doesn't have it. This actually has been useful to me in multiple scenarios. There's another thing we can do in window function. So we've talked about order by. We can also partition by. What if we want row numbers for dogs ordered by the oldest first, and then we're going to use the name as a tiebreaker, but we want different numbers. This is actually easier to explain looking at the answer, right? We want the sex of the dog to have its own numbers, right? So in this case, where sex is F, the oldest dog is row 1. The next oldest dog is row 2. But then we start over for dogs. We have partitioned by this column. So it's grouping by values in there. And it's determining the row numbers just for this window of data. And I feel like it really is with the partition. Partition is optional, right? We didn't even use it in the first ones. But I feel like it is with like when you introduce this partition by that, you're like, oh, this is a window. This is a group of data that I am now creating a row number for. And then, so we get row numbers for this first group, and then we get row numbers for this second group. And they are that we order by the age descending. And then if we did have ties, which we don't have ties now that we are partitioning by sex, but if we did have ties, then the name would be a tiebreaker. There are lots of windowing functions. You can do really cool things with this. There is rank. So rank, check this out. This is just basic rank. We also have dense rank. This helps handle those ties for us. Now notice this time that I did order just by age descending, right? So Mr. and Coda are the same age. You know, with row number, I had one was ranked 1 and one was ranked 2. So, but like if I really did want to rank them based on their age, both dogs who are 10 years old should be ranked number 1. They tied. Right? So row number doesn't do that, but rank does do that. So based on, you know, ranking with this. Now, rank, the way it behaves if I have a tie is for the next dog. So Wendell is the next oldest dog. Wendell is 5. Since 2 dogs got rank number 1, Wendell gets rank number 3. That's the way that the rank function behaves. And, you know, whether you want this behavior really depends on just the rules around your data set. What are the rules of your contest? If 2 get the gold, should there still be a silver, right? That's just a business question to answer. If someone should get silver, then you want dense rank. So running dense rank, this is the exact same syntax, but we're using dense rank instead of rank. In this case, once again, Mr. and Coda tie for the oldest dog competition. They both get rank number 1. But because we are using dense rank means if, you know, we use all the ranks, we don't skip if there's a tie, right? And we could skip with rank, we could skip more if there was a tie of 3 things, right? We would then skip a little more. So this one says we're going to just rank 1, 2, 3, 4, 5, etc. It doesn't matter if there are ties. We will still show ties, but we won't skip any numbers. I never can remember this. I'm always like, I know there's 2 rank functions, and I have to look at the docs to see which is which. The names do make sense. I just am unable to remember it. That's what the docs are there for. We can also partition when ranking. Same query, but we are grouping. We are creating windows. So, okay, now we have partitioned by sex. Now notice I didn't order by here, right? So I didn't do an order by. So even though I partitioned by sex, I have Mr. here, Wendell here, right? They're all mixed up. So just that is, I think this is on purpose. It is useful to know that the windowing function will not determine the display function, right? If you want to order by something, you always have to put it in the query itself. So we want to order by, let's order by, it often does make sense to order by what you are partitioning by. And then we'll do age descending. We will not autocomplete stuff into there. I mean, we will, but it's an accident, so we'll undo it. There we go. So now the females, Coda ranks 1, Scout ranks 2. Because Coda's 10, Scout is 2. And then the male dogs are ranked accordingly. Average, which we've talked about average before. We talked about average in group by. And so this first one is, we've already covered this, right? So we already covered that, by the way, you have to be mindful of your data types. If we just use average on an integer without converting it to a more detailed integer, I've taken the sloppy, easy way here of just multiplying it by a decimal 1.0. But like if we want an actual average that can contain part of a number, we do need to deal with integers, right? So we cut this, just a recap of that. The new bit is that if you would like to use average with windows, you can. So what is the average age for male dogs in our male dogs in our data set versus female dogs in our data set? What is the average over the entire data set? So this over blank, let's just add in, right, this one to compare, right? Notice here I have this over blank. That is optional. It's just that you can spell it out if you want. Oh, and what have I done by changing that? What is the error? Combos.dbo. Oh, they are not interchangeable. Hang on. I forget things really quickly. Okay, so running this query here, the previous query, this is average. This average that is not a windowing function, right? It has no over clause. Note that I did group by on this query, right? If I try to run this query without a group by, it's still like I'm aggregating here, right? I need you're not grouping by this column, so it can't be in the select list. Like it will only let me use this average with a group by, the average of what group, right? What the group by does is it tells it how should I, well, it's hard not to use the word group. How should I don't even know a synonym for group. How should I partition the data is the only other way to say this. And in this case, I'm saying by sex. If I use average as a windowing function with the over clause, essentially what I'm telling it, and I seriously have issues with this like IDE. I'm so jumpy in it. I apologize. So if I say average of this over this set, I'm saying over the entire data set. And I don't have to have a group by down here. This one I'm saying I want the average for each male or female of dogs because I only have male and female dogs in here, right? If I did have another sex in there, it would also group them. So we can see on this table that here are the two female dogs. One is 10, the other is 2. The average by sex is 6. The average overall is 5.6. For the male dogs, the average for male dogs is 5.5, but similarly, right, I do get this for every single row, right? Because what I'm saying when I do this, I haven't grouped by anything. I am getting every row in doggos because I haven't put any where clause on there. For every row in the doggos table, I want this information for this row. So unlike the group by query, right, it's not giving me aggregate information in a single row for the entire group. But I am able in windowing functions to get aggregate information for a window of data in the table that row is a part of, right? This row is a part I have partitioned by sex. So this row, average age by sex, is for female. This row is a part of the entire data set, so I am able to get average age overall there. There's also things like median. It actually used to be really hard to calculate median in SQL Server. You'll find code samples for it. You can do it, but it's just not simple code. SQL Server 2012 introduced percentile cont. There's another one, which I don't have an example for, named percentile discrete. You can play around with it if you want. The difference is just that the continuous percentile will just find the true median, whether or not you have that in your data set. Percentile discrete will find the median, but it will find the closest value that's actually in your data set. So here is a query that contains not just what we did before, the average by sex, but also the median age by sex, which happens to be for the girl dogs, it is the same. The median is the same as the average, but for the boy dogs, the median is actually a 4.5. Right? And we can also see for this for overall. Max and count can also use windows. So if we want to count the dogs by a variety of things, we can count as well. So we are doing the maximum age for that sex of dog and the count who have that age for each sex of dogs. So we can see that, let's try to get the query in here as well as the results. We can see that the maximum age for female dogs is 10, because code is 10. And there are 2 female dogs. The maximum age for male dogs is 10, because Mr. is 10. and there are 4 dogs, but there are 6 dogs overall, and the max age overall is 10. Running totals. So running totals is sum with a window. Complicated. What if we wanted a running total of the dog's age, right? So what is, and this, normally you would do this with money, but you can do it. We don't have money in this table, so we're doing it with age. So we have said we want the sum of the ages over order by age, and this gives you a running total. So Scout's age is 2. We start with 2. Stormy's age is 3. We have 5. Fletcher is 4. 5 plus 4 is 9. Wendell is 5. 9 plus 5 is 14. Coda is 10. 14 plus 10 is not 34. 14 plus 10 is 24. What's happening here is that because I ordered by age, these 2 rows have a duplicate age, so it does the running total for both of those rows. If we want the running total to be distinct, what if I order by dog ID? Well, dog ID, right? We don't have any duplicates on dog ID. Now, I haven't ordered by age in this case. I've only ordered by law, but notice that we don't have any duplicate dog IDs, so we do get a running total here. If I wanted the running total ordered by age and dog ID, right? Let's do both, right? So now we have, let's take a look at this. Some age, and I'm just ordering by dog ID here, right? So let's order by age, descending. There we go. Just easier to read this way. Oh. I am ordering now. Yeah, I think if I want to do this, I have to actually do it that way. Yeah, so I am now ordering by dog ID and then by age. So, Mr. is 10. Yeah, we still are actually, right? So the one I need to have my order by be the same here just for, it's because, right, I shouldn't change one part of the query and not change the other. There we go. So Mr. is 10. Right? But we are ordering first by dog ID and then not by age. Can I actually do a running total for age and order by age and not have it do the duplicates? I'm not actually sure. I mean, there might be a way to write it as a more complex query and do it. I actually don't know. That's a fun challenge. I will try to assign that one to myself as homework, but I am going to reset that so I don't get confused. We can, of course, do a running total with partitions too. So if I want to partition them by sex, order by age, and then do a running total within that window, right now I have partitioned by sex, and I am doing a running total for that. Then we start over again when we go to the next one. So I think these are super fun. You have homework, you have challenges to do windowing functions. This is our next to last session in TSQL for beginners. So next week we will go over solutions for window functions, and then we will dive into stored procedures. Thank you for joining me for TSQL for beginners. I'll see you again in another session soon. Bye, folks.